My name is Jit Biswas. I am part of Google Cloud. My partner in crime, Bill Varner. Uh, we are, I'm a principal architect in the Google portfolio. Lots of familiar faces in this room, so thank you. I know the conference is drawing to an end, so I am standing in between you guys going home and to wherever you are. So we're going to keep it tight, and that way you guys can be on the road. So today we are going to talk about some of the energy use cases that we see coming out of the woodwork. Obviously, last year was a huge change in priorities for a lot of companies. And today we are standing in a field where there's a lot of different initiatives happening, both from a sustainability side as well as from a real-time energy, core business standpoint. So we decided to lean on some of the things that we are working on in Google Cloud. So, for example, back in the days, I remember like even 10 years back, people would call us and say, I want to do AI, but I don't know what to do. I don't know what the use cases are. Can you tell me what the use cases are? And one of the most frequently asked use cases was predictive maintenance. Can my operational equipment, whether they will fail on me, and it will fail catastrophically, it will bring my plant down, and so on and so forth. And predictive maintenance was a use case, one of those, quintessential use cases that we talked about for the last 10 years. And all of a sudden, that journey has changed pretty significantly. In fact, the last presentation, gentleman talked about time series data and forecasting based off time series data. Just time series data itself has evolved very significantly in the last 2 years, whereby the data coming in previously was all we did some statistical modeling on top, univariate KPIs, and boom, we got some kind of forecasting with seasonality built in and so on and so forth. All of a sudden, today, time series data has got so many KPIs, so many metrics that we are monitoring that univariate doesn't work anymore. It's become multivariate. So we used to use ARIMA Plus as a model for forecasting time series. All of a sudden, that's changed. And we're using Vertex forecasting today, which doesn't necessarily require statistical data. You can do a cold start from no data at all, and you can still predict what's happening in the future. So from a data management standpoint, one of the things that we are noticing in the field is that it's essential to have your data foundation right before you go on the ML journey. And we walk into a lot of shops where people are just trying to do ML without doing the foundation right. So oftentimes we have to get the data in shape, labeled properly, make sure you're collecting the right data. I was recently at a company, and they wanted to do causal interference on data that's just coming in. They just don't know what's causing what. They just want to find out, based on Bayesian statistics, as to how to do causal interference, what causes what. Here's my data. Tell me what's causing this behavior. And we at Google, we work on some of these exotic ML algorithms whereby we can predict some of these causal behaviors across many different industries. And then, of course, there's this whole IoT platform, whether it's SCADA data or whether it's industrial IoT of some sort, or Pi data or something coming in from your your plant side of the house. There is, of course, a lot of that data that walks in, and you want to do some kind of AI on top to predict or to evaluate certain behaviors. I mean, in the energy industry, you know exactly how catastrophic it can be when something fails. And the ability to predict that and do something where things fail, let's say you have a flow meter that just fails on you, like prematurely, and boom, the plant goes down. So we do some of those work whereby you can either do visual inspection or you can do inspection based on data that's coming in from industrial IoTs. So, for example, over here, whether it's original equipment improvement or it's yield improvement or cost reduction, we work on many of the different AI components of that side. Visual inspection, of course, is huge. You're walking around in a manufacturing plant and you want to find out what's not right by a video or image, and you want to label them, and you want to know what's controlling what. So that kind of AI, of course, has been like detection, object detections, and so on and so forth. Then there is, of course, digital twins. Everybody in this planet is doing digital twins. Another thing that has evolved quite significantly over the last 3 years is anomaly detection. We used to do anomaly detection on any data, in every damn industry. But the whole industrial IoT data and the ability to look at huge volumes of data and be able to predict things based on anomalies in data has become very, very serious. We even have a log analytics capability today where you can look into hundreds of petabytes of data and be able to say what are the anomalies that you're observing. Whether it's people behavior, whether it's security behavior, whether it's just IoT data that's you're seeing some anomaly over there, point it out, because nobody really has the time to go into every little data set out there and visually look at it. So today, anomaly detection is becoming almost like an industry standard, given the volumes of data that's coming in through the pipe. Root cause identification, again, some of those, the RCA analysis that we do, what happened? What caused this failure last night? Or why did my production go down yesterday? All of that analysis is today available either through ML algorithms that we have developed. Some of this is industry standard, some of this is Google's IP. And we bring in those algorithms so as to make use of the TPUs that we have developed within Google so that we can process this data in a very effective fashion so that you can have the benefit of the speed and efficacy of some of these chips that Google's developing. Inline quality control. I come from a manufacturing background from my yesteryears. I was a metallurgist to start with, so I've worked in manufacturing plants in my yesteryears. And inline quality control was almost like unthinkable when I started my career. Today, you can have visual inspection AI, look at things, even find whether you filled up your cream pie with cream. And it's funnily, it's used significantly by the manufacturing companies out there to detect things that are visually detectable, either by color or by just imaging techniques that way you know what's right and what's not right, so from a quality control standpoint. And then we have the manufacturing data engine, which gives you capabilities of getting insights out of your time series data. So anything that's coming in from your industrial IoT data, you can connect to the manufacturing data engine and plug it in to our time series insights engine, which essentially gives you capabilities of detecting stuff and not have to write your own algorithms. This is all already ready to be done. You can just plug and play. This is an end-to-end architecture of an edge-to-cloud location for most of you who are working in the energy sector. There's some sort of edge processing that's going on. There's a lot of data being processed in the industry whereby things are coming in from some IoT sensor or some edge server out there. And the ability to process that data at scale in real time, we have the architecture and the capabilities to process this through the whole value chain so that you can get those insights in a timely fashion. How am I doing on time? Okay. The smart factory, essentially, today we have either its connectivity, data processing, you're having a common data model. So Google built a product called Cortex, which takes your SAP data and puts it to a common data model whereby you can get the insights from it from a BI standpoint or from anything that you need to do from a reporting standpoint. So you build that common data model which feeds off your ERP data in your, if you look all over Houston, SAP is like pretty much prevalent. There's few pockets of Oracle ERP, but it's mostly SAP. And taking that data from a business intelligence standpoint, processing it in the Cortex framework, we have an exclusive capability to process that data, ingest it from SAP and bring it to this common data model and be able to process it and give the business insights. There's also, factory analytics and insights that you can get from some of the data that is not just coming from ERP, but it's also coming from other data sources within the organization. And having the ability to have those insights and capabilities to do any kind of anomaly detection, predictive analytics, BI, and reporting, and any ML that goes on top of it from an ML ops standpoint, all of that has been done, and you can take advantage of some of the automation that has already been worked on. So we already talked about this. On the digital supply chain platform, that having a digital twin, this is something that is a pet peeve for a lot of people in this room, possibly. Having the capability of having that representation of your equipment in the digital format, that entire architecture has been created, and feel free to lean on us if you need anything in this space, because I could just talk about this for a whole day. So this is a architectural component which has many wheels, and it is something that you can avail of if you are interested in these architectural patterns. Last but not the least, on the sustainability journey, we of course have taken ownership of a lot of different initiatives from a sustainability standpoint, and my colleague Bill Barna is a specialist and an industry lead in this space. Bill, over to you.
Good afternoon, everyone. My name's Bill Barna. I'm a principal architect with Google Cloud. My background is in geospatial and remote sensing or Earth observation. My specialty is in working on the emissions problem in oil and gas. In this role, I work with our customers to teach them how to use Google tools to build their own solutions, and I also work with our partner ecosystem to be able to develop solutions for our partners. So I'm going to go through a few slides today that show you the different types of projects we do around methane emissions for oil and gas. First slide. Start out first with the regulations that we're trying to meet. A few months ago, the Biden administration announced a new set of enhanced methane rules that under Method 21, 40 CFR Part 60 Quad OA. And this requires technicians to go out with an optical gas imaging camera periodically, go in and survey different sites, and then report the data back to an EPA database. If an asset's out of compliance, basically there's a process to go in and bring it into compliance. There's a second program in the middle. It's called the Super Emitter Response Program. The EPA is going to be enabling private companies and NGOs to go out and use their own remote sensing technologies to find super emitters. A super emitter is defined as any methane source that exceeds 100 kilograms per hour. Most oil and gas companies are not going to want to get caught one of these because the remediation process is all done in a public forum. So we're working with technologies to let the oil and gas industry, the operators, be able to find these problems before the airplane does when this program goes into effect. And the last area is around the European Union. A few months ago, the European Union announced that starting in 2027, it was going to require the United States and other LNG importers to provide data, Scope 3 data, about the amount of methane emissions that escape during the production of liquefied natural gas. So our customers need to build solutions for this. Next slide, please. From the audience here, how many have heard of MethaneSat? Anybody? A couple? So MethaneSat is a new satellite that went up 2-3 days ago, was paid for and sponsored by the Environmental Defense Fund. The data is flowing directly to Google. It's the world's first Class 2 methane satellite system. It's designed specifically for studying regional methane. It's got a fairly sensitive sensor, but it's got a fairly large pixel size, medium spatial resolution. It's very appropriate for doing benchmarks on various leases. What you're looking across the top is a picture of the satellite. Across the bottom is sample data that we actually use the same spectrometer in an airplane. And so what this data is going to be available, it's going to be available through one of our products called Google Earth Engine. Should be available in a couple months. Next slide, please. Speaking of Google Earth Engine, this is a demo that I do for my customers. What you're looking at are methane plumes that were generated by NASA JPL spectrometers in their aircraft. This is all open source data. And the purple, the darker the color, the more methane in the air. And we also bring in feature layers from different state-level databases. So for this, I brought in the data from the Texas Railroad Commission showing all the different wells. You're looking at Loving County, and you're also looking in red the different leases. With this information, we can go in and identify the sources of super emitters. Remember, I mentioned the Super Emitter Response Program. They'll be doing something very similar. Next slide, please. What you're looking at here is Maxar WorldView 3. Maxar has a satellite, WorldView 3, that has that tracks 8 bands in the shortwave infrared. With a little bit of raster math, you can actually develop these plumes. And what we do is we use this data, we bring it into Google Earth Engine, isolate the plume, and calculate a flux rate. Remember I said a super emitter is anything above 100 kilograms per hour. So for our customers, we show them how to do this, we give them the calculation to calculate the flux rate. Next slide. This is a discussion on AI. Part of what we do is we have to identify the different assets. So what we do is we use satellite imagery and computer vision, and we go in and take automated inventories of different types of oil field assets. And we combine that and match it up to the different types of emission sources that we identify. You notice I've got a partner logo across the top. That's Blue Sky Resources. They do a lot of my hackathons and workshops. They bring in kits so customers can build their own systems. Next slide, please. And the final product, what we do is we extract feature-level data, which goes into BigQuery, about the specific emission source. This specific data came from NASA JPL for Loving County, and those are the stats on some of those plumes. So we extract that information, put it into BigQuery, and then it's available for more analytics.